Professor Monte, and we're talking about the intersection of two sets. So the intersection of two sets A and B is the set of all elements A and B have in common. All right, so the notation looks like this, like an upside down U. We read it A intersection B or A and B. Okay, so intersection means and. It's what the two sets have in common. It has to be in set A and also in set B. Sometimes they refer to this as a conjunction. Okay, well, let's look at some examples to see how it works. So this is called a Venn diagram. Each circle represents a set. So this first circle is the circle A, the set A, and it has the numbers 1, 2, and 3. And then set B has the numbers 3, 4, and 5. I like this because it shows us visually what intersection means. It's where these two circles intersect or what they have in common. And where they intersect, the only thing they have in common is that number 3. Well, A intersection B is the value or values in that intersecting area. In this case, just the number 3. All right, some more examples. This time the set is the colors red, white, and blue. That's set A. Set B is the colors white, green, and red. Well, if we look at that, we say, okay, let's look at everything in A. Red is red in A and B. Yeah, it's in both, so we get to include red. What about white? Yeah, white's in both. So it's in A intersection B, A and B. And then what about blue? No, blue's not in here. And notice, I don't have to go in here and look to see what's in here, because if it wasn't in set A, it can't be in the intersection. It can't be in both sets. So once I go through all the list of what's in A, as far as intersection goes, I don't have to look any further. I'm done. So A intersection B, or A and B, is red and white. All right, and then let's look at a couple examples using inequalities. So I've got the set A is the set of all values for x such that x is less than 3. So I'm going to go to a number line. Down here I've also got a 1, so I'm going to put a 1 and a 3 on my number line. All the x values less than 3, I don't include 3, so parentheses, but everything to the left of that. Those are all the numbers less than 3. Set B is the set of all x values such that x is greater than or equal to 1. So I include the 1, so bracket, but everything to the right. Again, A intersection B is where these would intersect or what they have in common. And what they have in common is everything from 1, including 1, all the way to 3, but nothing past there. So this time I'm going to write the answer as the interval from 1 to 3, including 1, not including 3. And then let's do one more example of that. I've got sets A and B. Let's say I have a 2 and a 5 this time. We'll put 2 and the 5 up there in the proper order. X greater than 5, that's anything off to the right of 5. And then x less than or equal to 2, that's anything to the left of 2, including 2. But notice this time they don't have anything in common. So the solution is there's no solution. Sometimes they'll say the empty set. Sometimes they'll write the set notation and put nothing in it, the empty set. More often, they would put the 0 with a slash through it, often called the null set or the empty set. That's usually what they would write. Both of these are perfectly acceptable. Depends on what your author or what your instructor are looking for. But that's the answer. Sometimes someone may even say no solution. So just do it the way your teacher wants you to. But that's it. Typically, I have my students put this. But if you're not in my class, you have to do whatever your teacher wants you to do. All right. Hope that helps. Practice these. You'll get them pretty quickly.